So let's take those conditions we were playing with before. So A, income is greater than 10,000. B, income is less than or equal to 20,000. And let's add a C. We have at least one tenant. So 3 conditions to play with. And let's say that we want to look at the condition where A and B are both true, or C is true. So then I want to combine these in the following ways. I want to consider A and B, and I'm looking at that first together. And then I want to combine that with an or if C is true. So like you might get a tax break if your income is in this range, or you have at least 2 dependents, or at least 1 dependent. So we're going to make a truth table for this. All right, so page. So to do that, I'm going to have to break it down. I have 3 things in there, so that means that's 2 times 2 times 2, or 8 outcomes that could possibly happen. So my truth table is going to have 8 rows. I start off looking at A, then at B, and then at C. And then after that, we'll start adding to the table to build the rest of it. And so to build the rest of it, we're going to follow the order of operations. So if you think about this was an arithmetic problem, and maybe this is like addition and subtraction here and here, I first have to do what's in parentheses, then I can move outside the parentheses. So the way I attack the truth table is I have to calculate the truth of the falseness of that first, and then I can move on to do the whole thing. So we'll add that into the table after. So you build the truth table. You look at some of them in the book, and they're like, holy shit, that's huge. How can I possibly wrap my mind around that? And you don't. You do it a little bit at a time. So let's do this. So there's 8 possible options. And the way the trees kind of work out on this is you take your first one and you split. Half the time it's true, half the time it's false. So that means there's going to be 4 trues and 4 falses. So for A, I'm just going to go down here and mark. True, 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 true. There's the first 4 possibilities. And then false, 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 false. There's the next 4 possibilities. Since I broke A down into 4 and 4, for B, I'm going to alternate by 2s. So for this, I'm going to go true, true, false, false, true, true, false, false. And if we draw the tree like we did for the 2 statement situation, we'll see the tree kind of leads this. And then the last one, if I went 4, 2, the next one's going to go all ones. And so for C, it'll go by 1. So true, false, true, false, true, false, true, false. And if you follow that pattern, you now have every possible combination of true and false for A, B, and C without repeating it. And this is the table version of making a true. So for you visual learners, I'm going to draw the tree, but then come back to the table. So as far as the tree goes, like how this scheme comes about, the tree, I have A, B, and C to consider, and A can either be true or false. Based on any n branch of A, B gets to happen. B is either true or false here. B is either true or false. And then these are four possible outcomes for A and B. Any one of those could lead to C. So then I start branching off for C. C is true or false. True or false. True or false. True or false. And so converting this back to the table, this one true value for A leads to four possible outcomes at the end. And that's why in the table, I had to write that true 4 times. If we look back at the tree, this one true value there of B leads to 2 possible outcomes for true for C and 2 possible outcomes for false for C. And that's why I split the B's 2 by 2. And then C, you can clearly see just alternates, true, false, true, false, true, false, true, false. The end of the branch will always do that. Doesn't matter whether there's 1, 2, 3 statements, or 5, or 6, whatever. It's always going to work out something like that. The first one gets half and half. The next one breaks down away from that, all the way to 1 by 1. All right, so back to my table. So order of operations on that statement I have means the next thing I have to put in my table is analyzing A and B. And we know from our previous table that A and B will be true if both A is true and B is true. So just look for every place in my table that happens and mark it true. So first row, true, true, got it. C isn't even mentioned in this column, so I don't even care about C right now. True, true, got it. True, false, false, true, false, true, false, false. Everything else is false for the and, for A and B. So I just go multiply. False, 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 false. Last thing is the final one, because this one only had basically 2 parts to it. I have to look at A and B. Oops, that mark there. Parentheses or C. So to analyze that one, all I care about is what this column says here and what that column says there. Now for an OR to be true, that means there only has to be one true present. They don't both have to be true. So anytime in these 2 columns I see a true, the OR is happy about it and responds with true. So with that, what am I going to get? Well, there's at least one true there, so this has to be true. There's a true here, so it has to be true. That's what OR says. Give me at least one true, and it's true. At least one, true. Oh, we got no trues, so it's got to be false. We got at least one true, it's true. No trues, it's false. True, 2 falses. So that's the truth table to try and figure out when a condition like this can possibly be true. Or I need both of these to happen, or this third option to happen. These are the possible consequences of that. So the ands and the ors aren't that bad, even when we start throwing them together in weird ways, even with nuts. And the bottom line is, you look at the statement and you think of it like arithmetic and you follow the order of operations, making one column at a time, and ain't that bad. Other nice thing about the homework on this stuff, in the homework, you just have to say whether each particular end cell is true or false. Well, if you get it wrong the first time, you better not get it wrong the second time, right? Because you know what the other option
I
has to
just
be.
did those, and I'm
Right.
like, okay.
So it's super easy to get every one of these right on your second try. Don't just fly through and do that. Stop and say, why didn't that? I thought it was true, why wasn't it? Pause and think about it. I know it's a sunny day and you got other shit you want to do, but please try and pause for a second and don't just fly through in 2 tries. That I can see the I know you got a lot of stuff to do. I just want to get this over with. Try to pause for a minute.
Like the valid and invalid questions
Yes.
on the homework.
Yeah.
Like if you don't get valid, it's obviously invalid.
Yeah.
Like-
Okay. That works. Okay, so let's do another. The next one always blew my mind, and every 5 years it comes back to blow my mind. The implication in a truth. What's an implication? Does anybody remember what another way we could state what an implication is?
It's an implied answer.
Okay. So there's 2 words that we use to talk about an implication. We played with Excel last class using one of these words.
Yeah.
If, yes, if then. An implication is an if-then statement. Right? So given 2 statements, like A, Gary is wearing shorts.
Oh, okay. That is something.
B, the sun is shining. Here we go.
Hey, the sun is shining and you are wearing shorts.
I know.
Really? Boom.
Okay. So given those, I could say something like if A, the sun is shining. Oh no, sorry. If A, Gary's wearing shorts, then B, the sun is shining. So that's one way to state it. The other way I can state it is A implies B. And I usually write the double equal sign with the arrow. The book writes a single line with an arrow. They both mean implies. Implication and an if-then statement are the same exact thing, 2 different ways to word it. So we're going to try and make a truth table for an implication and then discuss why the hell it comes out that way. It takes a little getting used to. So these are my statements, A and B. Gary's wearing shorts and the sun is shining. So now I'm going to go to my truth table. A versus B. And then after we get A and B down, we need to figure out what are the possible scenarios for the truth of this statement. And again, this is super important. Whenever you connect 2 or more statements, you get a new statement. And it's a new statement. It's neither of the original statements. It's a new creation. Okay? Like a man and a woman have a little baby. That's the baby. It's a whole new organism. All right, so I have 2 things. That means there's 2 times 2 or 4 possibilities. So for the first column, I split those in half. So it's true, true, false, false. And then cut that in half, you get singles. So this has to alternate. True, false, true, false. So let's suppose that Gary is wearing shorts and the sun is shining. Then A implies B is true. If Gary is wearing shorts, then the sun is shining. That's true. And so you can think about it as like a promise. I promise that when I wear shorts, the sun will shine. Now, granted, there's no causation there. I cannot make the sun shine. But I'm making that statement anyway. And either I'm wearing shorts or I'm not, true, false, or the sun is shining or it's not, true, false. Next one. Now, I made a promise, right? I promise that's what an implication does, it makes a promise. I promise if I wear shorts, then the sun will shine. I wore shorts. The sun didn't shine. I lied. That's false. That's bad. Okay. Now, my only promise is that if I wear shorts, the sun will shine. I made no promises about the days I don't wear shorts. So the sun might shine and it might not. Since the first statement is false, I cannot make I can't say that the whole thing is false. I just don't know. So if it's not, so if it's not false, it's got to be true by default. So it doesn't matter if I'm not wearing shorts, it doesn't matter whether the sun's shining or not, that entire new organism up there gets to be true by default. I didn't break my promise, did I? As long as I don't break my promise, it's still true.
You
Which is
use this
weird.
in
That-
arguments with your wife.
She's a scientist, so she's probably better at this stuff than I am, because science is all about logic and reason, and deduction and induction. So the implication is the weirdest one. The implication is true, except the one time when the initial part is true, but we don't make good on the promise. If the second part is false, true false leads to a false implication. Then it falls apart. Otherwise, it's okay. No violation, no faults. And that just takes getting used to. So once you get used to that, and you have an implication combined with other crazy stuff, as long as you go back to that right there, you'll be fine reasoning through it one step at a time.
So what was the one that we were talking about, like, you have the ice cream or,
Okay, so that's a different idea, just related to what the word "or" means when I use it in this context. So that's about the inclusive "or." So really, I could restate that. That is the same thing as "and" or.
Okay, that's what I was thinking.
Yeah, so anytime you see an "or" in a logical context, it means "and" or. What the first thing could be true, or the second could be true, or they could both be true. Or they can both be false. But if they're both false, the whole thing's false. Yeah, so the only time an inclusive "or" is false is if both statements are false. All right. So again, I'm hoping you're reading the book. Please read the book, because I'm not going to go over everything in there the way it is, but I do expect you to read it. I'm going to see if anybody's reading, and you guys can help me with a quiz. Quiz is time. We only have 30 minutes for this, so we better do good. All right, so let's see. The first couple aren't that hard. This is a good one. Let's see if we can get through what the spreadsheet is telling us here. So let's blow this up a little bigger. All right, so we got the expression, if whatever is in A1 is greater than 9, then we take 4 times that number, else we take 10 times that number. Remember how we read, and if there's a branching statement based on the truth of the first statement right there. So let's suppose A1 happened to have 5 in it. Does that make this statement right here true or false? False. So that means we jump to the second part here. So then we take 10 times A1, so this one here should be 50. If A1 happened to be 11, 11 is greater than 9, that's true, then it should jump to this spot here, and we should take 4 times that, so we should get 44. That makes sense, the way the if-then statement works? We did that class the other day. It's a branching. So it asks for, first there's a condition. If that condition is true, you do what comes first. If that condition is false, you do what comes second. And either a statement, according to a computer, is true or false. I know in English, we can make up stuff that you can't decide at the moment. Computer can always decide. It's either true or it's false. It's going to decide one. So let's see if we got it right. Yeah, all right. Let's do a truth table. Let's do it more challenging. We kind of just did that one. Ooh, yeah, this is a tough one right here. Okay, let's do this one. All right, so I'm going to copy this into my worksheet and see if we can make any sense out of it. So, new page. You guys can help me screenshot it. Now, ultimately, we want to answer that, but remember, we got to break it down before we can get to that. So, to actually do a table for this here, before we can do the whole crazy thing, we have to kind of follow it in terms of order of operations. Order of operations means we have to do what's inside the parentheses first. So we have to add a column for A or B. We also have to add a column for not C, and then we can do the implication.
So it's
So-
just the opposite.
It's just the opposite of C. And a lot of people could just look at that true and see it as a false instead. But there are days when I can't handle that and I want to write it out. So I'm just going to write everything out. So I'm going to have, where they have just one extra column here, I'm going to throw 3 columns in. Okay. So we'll come back to this. Get a new page up. All right, so we've got, okay. Well, so we have to write down our A, our B, and our C. Once we do that, we'll break out and write down our A or B. Then we'll write down our not C, and then we can do the implication. A or B implies not C. So that's my recommendation on how to handle this.
So that means not,
Okay.
okay.
Yeah, so the tilde means not. Yeah. So remember, so we have 3 things. 2 times 2 times 2 is 8. So that means we split it in half and go 4 truths and 4 falses.
And then you split that.
4 jumps to 2, cut it in half. True, true, false, false, true, false, false. Cut 2 in half, you get 1, and so now they strictly alternate. You guys are writing all this shit down. Make me nervous. And so now, for the first new column, we ignore C for a moment and just talk about A or B. So what does the or require to happen?
The or,
Yeah,
just one of the being.
at least one of them's true. It gets to be true. Okay, so ignoring column 3 here, as long as we have a true, we're good. Okay. So it's mostly true. For not C, we just flip all the values in column 3. So instead of true, false, it is false, true, false, true, false, true, false, true. You texting this to your girlfriend?
No.
You better.
Okay.
All
My
right.
adopted mother.
Okay.
I was texting too.
All right, so next, we try to do the implication. And the thing to think about an implication, the implication is only false if there's a broken promise. Broken promise means we start off with a true premise and end up with a false conclusion. So any place it goes true, false, it's false, otherwise it's true. Yeah, so this top one, let's put that in new color, that's false, promise broken right there. True, true, that's true. True, false, promise is broken, it's false. True, true, good. True, false, promise is broken. True, true, this is easy. False, false.
True.
True, yeah, no promises are broken here. Gary didn't wear shorts, who cares what happens after? So that one is true,
True.
false, true, is still true. No promises are broken.
You decided to wear pants that day.
Yeah, and the sun's shining, so what? It happens.
Shit happens.
Shit happens. The sun goes out sometimes. Kind of thing. Did I ever tell you guys I used to live in Aberdeen, Washington? The sun never seemed to come out there, ever. Gosh, that was rough. Hello, all my friends in Aberdeen. I hope the sun is shining for you.
Seattle's the same way. Seattle's-
No way. Seattle's way sunnier than Aberdeen. Oh my
Oh,
gosh.
really?
Yeah, I lived in Seattle for a little while too. Seattle was pleasant. Okay, so it's like, what is that silly movie about the sparkly vampires? Twilight.
Yeah.
Yeah, they set that in the town north of Aberdeen called Forks. And Forks is as bad as Aberdeen. The sun does not shine much. So it's a good place to live if you're a sparkly vampire. Okay, so let's see if we got it right. Okay, so it was false, true, false, true, false, true, true, true. All right, so And the only way I can do these is I gotta break them down like arithmetic. I gotta take my time, I gotta write everything down, otherwise I'm liable to screw up. All right, now I forgot.
False.
Thanks. So it alternated for a
True,
while.
false, true,
False. True.
and the last three are true.
True. True. True.
All right, so now randomly guessing, you got a 50% chance on each try.
Yeah.
50% times 50% times 50% times 50. That gives you a pretty slim chance at the end. However, you're going to nail it no matter what on the second try. So, yeah, we got it all right. Look at
Actually,
that.
on the quiz, it's different. If you get it wrong the first time, then it
Oh, you only get one shot on the quiz, right? I was thinking of the homework. Yeah, the homework you get multiple tries, so you can't miss it on the second try. So I got to write them down. On a really good day, if I'm focused, I'm well fed, nobody's pissed me off, I can kind of look at that and reason it out without writing it down, but all the stars have to align for that to happen. And generally they don't. So write it down. Yes, right. Pretty rare. Once in a blue moon. All right, let's try another one. So the end of the chapter was all about these bad arguments people give. And some of these arguments, people give them so much they get special names. Okay, so we're going to take a look at some of these and see if enough of us read the book that we can figure out the right answer. So let's see if I can get to the right section. Let's blow this down a little bit more. You guys can handle that one. That one. Here we go. Okay. So there's something wrong with this argument, and it's such a common wrong thing to do that it has one of these special names. Appeal to authority, false dilemma, post hoc, circular reasoning, appeal to ignorance, straw man, ad hominem, correlation implies causation, and appeal to consequences. So let's see, pull it up a little. Since the 1950s, both atmospheric carbon dioxide levels and obesity levels have increased sharply. Hence, atmospheric carbon dioxide causes obesity. Wow, that's a good one, huh? Okay, so we all look at that and we're like, what? Okay, so another, if you believe that, have I got another one for you? Okay, so what do you? So let's look at, yeah, this is something my brother would say to my stepfather to piss him off. What do you think this one is? You're going for appeal to ignorance? No, that's not what this one is. No. Any other thoughts?
This one is a false dilemma.
No, a false dilemma is when you tell somebody there's only two options, but there's actually more. So they believe it's either true or false, but there's actually another option, like in between. Yeah. Correlation implies causation, yeah. So correlation just means as one thing changes, another thing changes. But they don't have to be related, and I have a hard time finding any scientific link that carbon dioxide levels cause obesity. Now, trees suck in carbon, so I can see high carbon levels might make trees fat, right? But not people, right? We don't process carbon like that. So this is correlation implies causation. Woohoo! Got it right. So just to show you another, this one always cracks me up whenever I see this one. So anyone ever watch like Pirates of the Caribbean? Yeah. That's one of my favorite Johnny Depp roles. He's done some other good stuff, but that's a great pirate movie. There used to be more pirates around, and then they started going away. Now there's been a resurgence, right, around parts of Africa, but the number of pirates have been dropping. So pirates, population has dropped 2 P's since the 1700s. On the other hand, shortly after that, the Industrial Revolution kicked in, and we started billowing smoke into the atmosphere, and so the average global temperature started to rise. So average global temperature
It says that fires in the way global warming.
Temp has been rising. So one thing politicians aren't talking about is if we just create more pirates, the global temperature will drop. We'll take it back, right? So save the planet, become a pirate. That can be our new motto, right? So this is
good.
called a negative correlation. As one thing goes down, another goes up. Whereas the obesity rate thing, that was what's called a positive correlation. One went up, the other went up. You can go have correlation either way. Causation, pirates versus global warming, that's way crazier, right, than the global carbon and the obesity rates.
Yeah, on the written assignment,
Yeah.
like, I was making sure that it said obesity. Like, I was making sure I read it right.
Yes,
I read some of
obesity.
the written ones.
Yeah.
Like,
Yeah, I'm interested to see what people write to me on some of this. Okay, so let's try one more, and then it's a sunny day. We should quit for today. All right,
What
so
was
let's.
which number?
That was number 10. Hey, and we still have an hour and 16 minutes to go, and we've already done 3 of the hardest problems. Okay. All right, here's another one. So, John Bardine's work at the Advanced Institute for Physics has progressed so slowly that even his colleagues call him a plodder. Hence, it is prudent at present not to take seriously his current theory relating to how strings constitute the smallest subatomic particles. Okay. So, John Bardeen is slow. It implies his work is crap.
pretty much.
Okay, so this is a common argument people use. Which one of these?
Ad hominem.
Ad hominem. Ad hominem, let's see, I know what that means. Remember what ad hominem means? Ad hominem. I have it in mind. Post hoc means you made shit up after. I forgot. Let's look it up. Math. Look at the book. That's one thing. This is an open book quiz. You can just go look stuff up when you forget something. Look up. Let's shrink this down. Do anything you want on the quiz. I wouldn't let someone else take it. Oh, I opened up a new window. Now that can cause problems. So the smart way to do this would be to open up the logic page ahead of time in a different window and then have it. So I could screw up my quiz here. That is possible. If I try to open up a homework problem, that will definitely screw up the quiz. I can tell you that. I've done that.
First open up the reading.
First open up the reading, yeah, and then take the quiz. This shouldn't mess it up, but you never know.
I have ad hominem right here on Google.
Oh, yeah? Okay. Let's see.
Latin
You-
for to the man or to the person.
Oh, that's what a personal attack. That's right. So ad hominem means you're attacking somebody, and your attack is why, like, Gary Parker wears shorts a lot and looks like an idiot in shorts, and so don't take his math class because you're not going to do well. Okay? You're attacking me, right? It's got nothing to do with why that could be possibly
So
so
it's essentially like Trump's haters.
Yeah, don't go for Trump.
Destroying him.
Yeah, because Trump, I think
Like
Trump's an
ever
idiot.
since his fence theory, it was just all downhill from that.
Yeah, that's going to be a tough one to
To
overcome.
keep everybody out.
So ad hominem means there's a personal attack.
Okay.
People still get him.
So
Yeah, it is.
they are saying he's slow. Yeah, so it could be a personal attack. Yeah, let's see, what else could it be? Yeah, so he's slow, so his stuff is
What
worth.
is the straw man one
He's
again?
not good, so.
I've actually heard straw man a lot.
Yes.
I don't remember.
So let's look up straw man. That's later down here. Another nice thing is Control F on the keyboard. You just type straw. Oops, I can spell it. Okay, straw man. You're misrepresenting the argument in a less favorable way to make it easier to attack. So basically, you're doing an exaggeration. You're exaggerating the facts in order to try and sway somebody toward your conclusion.
That's a toss-up.
Okay. So that's straw man. So it could be ad hominem because they are attacking him. Straw man means they're making some kind of an exaggeration. It's prudent to not take his work seriously because he's slow. Circular reasoning, you're coming back with what you started with. Like, all humans are good because I think humans are good. Oh, sorry. We did it's correlation implies causation, so that means two things are changing, and we say they're connected. Okay, that's not what's going on here. Appeal to consequences. No consequences here we're worried about. Post hoc means you're making stuff up after the fact. Appeal to ignorance.
Yeah.
Not this one. False dilemma means you're saying it's either true or false, but there's actually another possibility. And appeal to authority means it's like God said so kind of thing. So I think it's probably ad hominem. Any other, you guys come up with a better option?
I second.
Okay, ad hominem is what we started with. Submit, and let's go see our scores. I only did part of it, but I'm going to go to take this anyway, and I got it right. Yes. It's just question one. I can look at my screen, it's too big. Cheat. Oh shit. Not even rolled it. Oh shit, I'm not a student, so I can't take the quiz like you do, and it doesn't record it in the gradebook. So I can't see my result. Oops.
You're not even-
That, it was at home. It was at home. So, all right. So, word of advice, when you take the quiz, get the logic page out ahead of time, then sign into the quiz. When a truth table comes up, write it down by hand. If there's multiple steps, fill in each step before you get to the final consequence. Highly recommend. And don't forget to do the written assignments. Very important, where you get to write to me about some statements.
So on that quiz there,